Hi, so today we are going to use algebraic tiles and learn how we can use those tiles in order to solve math problems with integers. So what an algebraic tile is a little tile, a piece of paper like this. On the one side is the yellow, which would represent the positive, and on the reverse side is red, which would represent the negative. So these little squares here would all be representative for single digit numbers like 1. So this would be a +1, positive 1, and this would be a negative 1. Now these long bars here would be representative of the number x when we don't know what the number is. So again, the green means positive x, and the red would mean negative x. And then this you can use later on. We're not going to actually get to it today, but I just wanted to show you what it was. This is big square is actually x squared. So again, this would be positive x squared, and this would be the negative x squared. So today, when we learn how to use the algebraic tiles, we are going to first learn how we can see to solve a simple math problem, 6 plus 4. So what we need to do is take our positive tiles and bring out 6 of them. 1, 2, 3, 4, 5, 6. So that represents that number. And now we need 4 more. 1, 2, 3, 4, and that represents this number. So now we can take our tiles and we can count them. 6 plus the 4, so 6, 7, 8, 9, 10 would make 10. So we just solved with our algebraic tiles. 6 plus 4 equals 10. But what if we had a negative number? How can we use our tiles to solve that problem? So let's just try a negative 6 plus a negative 4. What could that answer be? So let's turn our tiles over. So we see the negative side, so that we the red, so we know that these are negative numbers. And again, we would just add up our tiles. So our negative 6 plus our negative 4, so 6, 7, 8, 9, 10, would make a negative 10. So how can we use this if we had a mixed number? Say a positive 8, and we're adding it to a negative 3. How would we do this? So let's turn our tiles over. So we have 8 yellow tiles showing for our 8 positive numbers. And now we need 3 red tiles to represent our 3 negative numbers. And what they would do is they would equal out. Our positive with our negatives would equal out. And so once they equal out, we take those away. So all that's left is 5 positive tiles. So 8 plus a negative 3 would equal 5. And that will work even if the negative number is on the front. So if we had 7 negative tiles, 1, 2, 3, 4, 5, 6, 7, and we're adding it to our 2 positive tiles. Again, the negative and the positive would cancel each other out, and all that's left is 5 red tiles, which would make it 5 negative. So negative 7 plus 2 equals a negative 5. So how can we use these algebraic tiles to solve an equation for x? So if we had an equation such as x plus 4, what would that equal? So we have our x number, and now we're going to add 4 yellow tiles. So what would our answer be? Because we wanted equations, so we want to know what is equal to. So in order to do that, we have to isolate the x. In order to isolate the x, we have to take away these positive 4 numbers, and we need to do it on both sides. So when we do that, this would cancel each other out. And then our 4 would all become a -4 onto this side of the equation. So x would equal -4. How else can we do it? So say we had an equation that says 2x equals 6. So both are positive, so we want our positive side showing on our tiles. So here's our 6, and here's 1, 2 of our x's. So how can we represent and show that what the 1x would be? So what we do is we take our positive numbers and we separate them equally. 1, 1, 1, 1, 1, 1. So we can easily see that this 1x has 3 and this 1x has 3. So what we did is we divided it both sections into 2, which would cross that out, so it'd make it a 6x, and our 6 into 2 piles is each has 3. So x equals 3. But how can we do that if we have a negative number? What if we have 3x and we wanted to know how much a -9 would be? So we have 1, 2, 3 positive x's, and we're going to figure out what our 1, 2, 3, 4, 5, 6, 7, 8, 9. So in order to do that, we'll take our x's and we'll spread them out a little bit, and we'll make 3 piles. 1, 2, 3, 1, 2, 3, 1, 2, 3. And so since we made them each into 3 piles, this is how we're writing it down. But then we can see that this cancels it out, so it's just plain old x, and -3 and 9 divided by 3 times 3 piles would get a -3. All right, let's try one other way. What if we had this problem to solve? 2x plus 4 equals -10. So how would we do this? Well, with our pile, we'd have 2x plus 4. 1, 2, 3, 4. And we'd have our equal signs, and we want -1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. So now, in order to separate it, we want to get the x by itself. So we are going to subtract 4 on both sides. So we'll take our positive 4 and we'll make them -4 and put it on this side of the equation. So these two will cancel each other out. And -10 plus -4 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. -14 equals 2x. So now to solve for x, we need to separate them into 2 columns again. So we're going to just take our tiles and just make sure that they're evened out. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's equal. So we were dividing it both into 2. So x will equal -7 because it's still a negative number, even though. All right. Let's try one other one, shall we? What if we had a negative 3x plus 5 equals negative 10? So, in order for us to solve, let's get our tiles ready. 1, 2, 3. And we're going to have positive 1, 2, 3, 4, 5. And now we're going to have our negative 10, 1, 2, which equals negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we want to isolate this x. But since this one, is a negative, so these need to be negative, we could subtract this 5 on both sides so that we have negative 1. Oops. 1, 2, 3, 4, 5. That one didn't flip over, did it? So now we have negative 3x equals a negative 15. So if we put them into 3 piles, 1, 2, 3, 1, 2, 3, we can see that each x, a negative x, equals a negative 5. But you know what? Negative numbers will cancel each other out, because you don't really want to know what a negative x is. So if we added an x to this side and we added an x to this side, we would have 0 equals negative 5 plus x. So what should we do? We should add 5 to this side and add 5 to this side of our equation, which then would cancel those two out. So then it would be 5 equals x. So we just move them around. So our negative 3x plus 5 equals negative 10 only if x is 5. Okay, I hope that helps on how to use algebraic tiles in order to solve math problems with integers. If you have any questions, let me know. Thanks.